I know this is probably going to make you sad or not, but this is not going to be a long video today. Let's look at macroevolution. All right. Now, macro, of course, means large, and we're looking at change on a large scale. So when we talk about macroevolution, we're looking at it, it's referring to the evolution of a new taxon from a pre-existing taxon. So basically, you end up with this new species or that's higher on the classification scale. So it's becoming more advanced. Now, Stephen Jay Gould is a Harvard professor, a famous Harvard professor, and he talked about this concept called punctuated equilibrium. And back in 1976, sadly, I remember the bicentennial year because I'm that old. So, Stephen Jay Gould, when we're talking about this punctuated equilibrium, what it's referring to is these very long periods of stability. That's our equilibrium. We're at 0.5, 0.5 for our P and our Q, okay? And so very long periods of stability, and then suddenly something interrupts it, some major disruption. And so we're talking about this suddenly part is it's punctuated. I mean, you're in the middle of a sentence and then you stop, you have punctuation there. So there's some major disruption, like an asteroid hitting the Earth or something along those lines. And it causes this mass extinction of the existing species. Well, that makes sense because there's going to be some big changes that occur. And after the disruption calms down, it's usually several years, you have this mass evolution of new species that are going to occur to occupy all the new open niches. I mean, your environment has changed. And so because your environment has changed, now there's changes. There could be more water, there could be less water, there could be change in temperature, change in air pressure, change in vegetation, change all kinds of things. And so it makes sense. So the new niche that's available there, it's like the primary succession or even secondary succession, but then that is now open where it wasn't before. So now it's available where it wasn't before. So because of this major disruption, now there's new species that can proliferate in that. So the punctuations usually mark or cause the end of an era. So these massive events, one thing will change, one will end, the next one will start. So this concept of the snowball Earth caused the end of the Precambrian era, where it's believed that 7/8 of the Earth was covered by ice. So we call it the Ice Age. It took, conceptually, if we're looking at gradualism, and then it would take millions of years for this to thaw out. So obviously, in that time, most organisms died. And those that survived were around deep sea thermal vents. Remember, we talked about the heat that comes out of those. And so they would be warm enough to support life. And then once all that ice melted, then we had the Cambrian explosion, and all these different species started in the beginning of the Paleozoic era. So this is called the age of the fish because there was water everywhere. All right, then we have Pangea, which again, we can look at it and we can see those land formations. They all fit together like a puzzle. And Pangea was the supercontinent. And this caused the end of the Paleozoic era, where the coming together of all the continents caused the Earth's water to be dramatically displaced. And so the interior swamps and oceans disappeared, and over time they became these vast deserts. And then you have most of the aquatic and terrestrial animal and plant species went extinct because of that water loss. So there was a change in the water, and it affected everything. So this mass extinction allowed for the supercontinent, or in the one big ocean. So the one big ocean that surrounded everything. And then the mass extinction allowed for the mass explosion of the new reptile species and desert plants. So we can look at this approximately at this time and see that there were more because that environment supported more of those. So those species would thrive in that kind of environment. Then we have um, an asteroid that hit the Earth, and the timing, of course, we're not sure of, but scientists will say 65 million years ago. So if we're looking at it according to gradualism and uniformitarianism, we're looking at about 65 million years ago, supposedly. But that it was that asteroid that caused the end of the Mesozoic era, and then the extinction of the dinosaurs and different plant species, because the sun was blocked out by soot and ash for years. And so globally, the planet became very cold because it didn't have the exposure to the sun. We even know that there was a volcano, I think it was in China. Gosh, I'm going to have to look that up. But it was so bad, or was it Mount St. Helens? It could have been Mount St. Helens. I'm losing my mind. But it was so bad that it caused the temperature around the globe to drop. And so you can imagine something as large as an asteroid hitting, and all the effects of it, and the soot and ash that went in blocked the sunlight. The planet became cold, and the only ones that were able to survive were mainly mammals because they had fur. And so reptiles, amphibians, and fish survive too because they're adaptations. Reptiles will sun themselves and keep them warm. They have ways to keep warm. Amphibians could bury themselves in the mud or go in the water. And the fish survive too because at least the water the temperature would be a little more regulated because of the bottom of the water, will keep it warm. So, and some plants. And then once the sun returned to the entire Earth, then we see this explosion of the mammals and what we would call the age of the mammals, or the Cenozoic era. So the concept is, when we look at microevolution on a small scale, then the thought is then that microevolution can cause macroevolution. If there's enough time and enough changes in the DNA. So you have mutations that occur. Are they adaptive mutations or non-adaptive mutations? And if you had a long period of time, what ends up happening as a result from that? Now, it's also important to understand that, when we talk about equilibrium, we're talking about long periods of stability, and that there's very little species change that occurs on a large scale. I mean, it just doesn't happen because we're at equilibrium. We're not talking about changes. So then the occasional punctuations of trauma cause these mass extinctions. So typically you're not going to have a mass extinction unless you have some kind of big trauma. And then you have, after the trauma, you have these mass extinctions that are followed by these large-scale explosions of new species, because we now have new niches as a result. And so new species can come in and populate. And then, so we start seeing these new traits at the beginning of a time period. Oh, you're so sad. But that's all we have for 7.3 part 2.